So we know that there are total of 5 topics in your chemistry paper number 1. Today and tomorrow we'll be doing your topic number 4, which is the introduction to organic chemistry and alkanes. Today we'll be covering with 4A, which is the introduction to organic chemistry. And tomorrow we'll be doing 4B, which is alkanes. So in these 2 classes, we'll be finishing off with your topic 4. And next week, your chemistry P1 syllabus will be completed. So in this chapter,
Okay.
we'll talk about the homologous series, the nomenclature, different function groups, systematic way, naming compounds, and isomerism. Mathematically, you should know about the ratios and stuff as well. So what is organic chemistry? The study of organic compounds. Okay. And since 1800s, our knowledge and understanding of chemistry has grown rapidly. Chemists has actually divided chemistry into 3 parts: inorganic, organic, and physical chemistry. And each category is equally important. And moreover, we have found out till now that there are different millions of different compounds. Today, organic has a very different meaning in everyday life, and it is often applied to farming and food. हमें लगता है कि organic का मतलब है farming, food, but special. कुछ
Mm-hmm.
special होता है उन substances के बारे में जिनको हम organic कहते हैं. What is that special things? Why do we compound? जैसे compound है called urea that is present in your urine. एक पर्सन के यूरिन के अंदर एक यूरिया प्रेजेंट होता है. इट इज ऑल्सो प्रोड्यूस्ड बाय ह्यूमन बॉडी. और इसको हीट करोगे तो वो एक नॉन ऑर्गेनिक प्रोडक्ट बनेगा. सो एक फिजिकल, इनऑर्गेनिक, ऑर्गेनिक में क्या फर्क है? कौन सा प्रोडक्ट, व्हाट प्रोडक्ट इज ऑर्गेनिक, व्हाट प्रोडक्ट इज इनऑर्गेनिक? We start off by studying the hydrocarbons. By the name hydrocarbons, you can tell that an organic compound that contains carbon and hydrogen only. For example, आपके पास जो alkanes हैं,
Mm-hmm.
alkanes contain carbon and hydrogen only. Then alkenes, they contain carbon and hydrogen only. The rest of the compounds, they also contain oxygen, nitrogen, and other.
Can
Uh,
they can also contain oxygen? Can they alkenes?
yes,
They also contain oxygen?
alkenes.
Yes.
No, alkane is
Can they?
single bond, and alkenes are double bond, and they only contain hydrogen, both of them.
Okay.
Got it?
Yeah.
Alkanes and alkenes both contain only carbon and hydrogen. This is a basic knowledge of your IGCSE chemistry. I'll otherwise send you all the previous lectures to revise as well.
No, I know, but I've seen some with oxygen and nitrogen.
No, वो इसमें नहीं है. No, never. Almost all of these compounds also contain hydrogen, and some other elements include nitrogen and oxygen as well. But right now we're going to talk about hydrocarbons. If an organic compound contains other elements as well in carbon, hydrogen, it's not an hydrocarbon. But for example, sucrose है, इसके अंदर oxygen भी है. It becomes a different type of compound, but it's still organic. It's not just a hydrocarbon anymore. So what is the
Yeah.
difference between saturated and unsaturated hydrocarbon? Saturated are the ones which have single bond. Unsaturated are the ones which have a double bond. There are many
Yeah.
thousands of different hydrocarbons. Most of them are classed as saturated or unsaturated. Like many chemical terms, these words have a very different meaning in everyday life. Someone who has been caught in heavy rain shower, his clothes are saturated, meaning that they have absorbed a lot of water. एक dry cloth होते हैं, dry कपड़े हैं, but अगर वो गीले
Yeah.
हो जाएं बारिश में, if they get soaked up in rainwater, we can call them saturated, absorbed, heavy. In organic chemistry, these terms have nothing to do with water, but there's a connection to it. All single bonds would be known as saturated, and if there's a double bond, we call it an unsaturated. You can see over here, this
Like,
is a saturated hydrocarbon, alkane.
yeah.
And then we have an unsaturated hydrocarbon, which is an
Alkene.
alkene. Here you can see ethane, this is ethene. You can see
Mm-hmm.
that
Yep.
carbon atom has 4 bonds. This is one thing that is sure, that carbon is in group number 4. It has 4 electrons in its outermost shell. But now is it going to form 4 single bonds or 1 double bond and 2 single bond? That entirely depends on the type of saturated or unsaturated that we are studying.
Yes.
The difference between a saturated hydrocarbon and an unsaturated hydrocarbon is to do with whether or not there is room for more hydrogen atom. If there is no room, then the hydrocarbon is saturated. If there is room, then the hydrocarbon is unsaturated. One easy way to decide whether a hydrocarbon is saturated or unsaturated is to look at the structures like the one above. Double bond means unsaturated. single bond means saturated. Over here, you can see as well, this is propane, saturated. This is butane,
Mhm.
saturated. Both of them have single bonds, they are saturated. Then we have cycloalkanes. Alkenes can also be converted to cycloalkanes if we remove the double bond. They are also saturated. They have just joined themselves in a ring structure. The first one has a triangular arrangement and the second one has a square arrangement. And these ring structures means that they are cyclic compounds. We will look at alkanes and cycloalkanes in more detail in your topic number.
But will they become alkanes, the alkanes?
Yes,
Because there are no double bonds?
yes, because they are not double bond, they are saturated and they are now known as alkanes. I just
Okay.
broke the propene into cyclopropane. So hydrocarbon is a compound that contains only carbon and hydrogen. Saturated means only single bonds. Unsaturated means one or more than double bonds. So what are the different types of formula? When you refer to organic compound, you should know their formula, their name and their structure as well. अगर एक सिंपल डिस्प्लेड फॉर्मूला को देखें, so this C4H10, this is what? This is known as a chemical formula. And what is this? This is known as a displayed formula. You can also write it as a structural formula. For example, this is known as CH3. Then next one we have what? Each carbon one at a
Uh,
time.
yep.
CH2.
So CH2, and CH3.
Exactly. This is known as a structural
Structural
formula.
formula.
Now you're going to be introduced with another new type, which is a skeletal formula, where we do not show any hydrogens, we only show carbons. So here you can see these ends, one, two, three, four, they represent carbons, and you can't see any hydrogens on it. This is
Yeah.
known as a skeletal formula.
Skeletal formula.
The word skeleton is connected with the word skeleton as you only the bones in the humans or animal body, which is a zigzag. And जो corners होते हैं, जो edges होते हैं, they always show you what? They always are going to show you the carbon atoms. Molecular formula over here, you can see this is your molecular formula. And if I have to convert it into empirical formula, it would be simplified to Ce2H5.
C, yes, the smallest number. I can't.
Now consider the formula C3H7Cl. This is clearly not a displayed formula or a skeletal formula. It is also not a structural formula. What is it? The chemical or the molecular formula, which tells you what is the chemical formula or how many or which molecules and how much of those molecules are present in that compound. So, of course, in very similar molecules such as CH3Cl, I can tell there's one carbon, three hydrogens, one chlorine.
Mm-hmm.
Empirical formula tells you the simplest
The one
possible
we did.
whole number ratio.
Yeah.
Exactly. जैसे if we talk about butene
Mm-hmm.
and if we talk about butane,
Yeah, that would be first one CH2 and the second one would be C2H10.
exactly. So these are the chemical or the molecular formula that tells you the actual number of atoms. And this is the
Yes.
empirical formula, the simplest whole number
The
ratio.
simplest one.
Different types of formula for chloroethane को अगर हम मजीद स्टडी करें, chloroethane is what? आपके पास दो मॉलिक्यूल C2H5Cl. Until now, we
Yeah.
have only considered the different types of formula using hydrocarbon as an example. Now we are adding a third element inside ethane, removing one hydrogen. So C2H6 से ये क्या बन गया? C2H5Cl. This is the
Yes.
displayed formula. This is the structural formula. This is the skeletal formula. अब skeletal formula आप देखो. If I draw the displayed formula, this is the structural CH3,
Yeah.
CH2, Cl. और अगर आप skeletal formula देखोगे, remove the hydrogens first. How would you represent carbon? This is one carbon, second carbon connected with Cl. This is known as
Yes.
a skeletal formula that you can
S.
see over here.
Yeah. But
Molecular
it's one line CH3. That's one line.
yes,
One line like up is CH3.
no, it's just carbon. वो depend नहीं करता.
Okay.
CH3, CH2 ठीक है. वो that doesn't depend one line up है. The corners and the edges would always represent carbons.
Okay.
Yeah. अगर ऐसे 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 है and then I add a OH. How many carbons are here? One, two, three, four, five, six. C6. H11OH. Got it?
Yep.
This is a skeletal formula over here. Molecular formula and empirical formula would be the same in this case because it cannot be simplified further. So displayed formula shows every atom and every bond. Structural formula shows how the atoms are joined together. Skeletal formula shows all the bonds between carbon. Molecular, the actual ones, and empirical, the simplest ratio of the molecular formula. Let me show you something about skeletal formulas quickly. So you can easily make it because it's a new concept as well. It's not different for CH2 or, CH3. All the corners
Yeah.
and all the edges are just going to represent you the carbon atom. You don't add hydrogen in it, but other than that, you represent everything else.
Hi and welcome back to Free Science Lessons. By the end of this video, you should be able to describe what's meant by the displayed formula, the structural formula, and the skeletal formula of organic molecules. In the last video, we looked at the molecular formula and empirical formula. Remember that the molecular formula of a compound tells us the actual number of atoms of the elements in that compound, whereas the empirical formula is the simplest whole number ratio of the atoms of each element in a compound. So for example, the molecular formula of ethane is C2H6, but the empirical formula of ethane is CH3. In this video, we're looking at three more types of formula used in organic chemistry. We'll start with the displayed formula and the structural formula. I'm showing you here the hydrocarbon propane. As you can see, propane has 3 carbon atoms and 8 hydrogen atoms. This diagram shows the displayed formula of propane. The displayed formula shows us the relative position of each atom, plus all of the covalent bonds. Now I should point out that the displayed formula does not show accurate bond angles. For example, the bonds around a carbon atom are arranged in a tetrahedron, with a bond angle of 109.5 degrees. Now rather than draw a displayed formula, scientists often use a structural formula. I'm showing you the structural formula of propane here. Now the structural formula shows us how the atoms are arranged, but does not show us the bonds. Now the key idea with the structural formula is that you need to show the atoms bonded to each carbon atom in turn. So this shows the atoms around carbon 1. Here are the atoms around carbon 2, and here are the atoms around carbon 3. This shows pentane. Now in the structural formula, we could represent each CH2 group individually like this. Or we can show the 3 CH2 groups like this instead. Either way is fine. Here are 2 different versions of chloropropane. These versions are called isomers, and we'll be looking at isomers in much more detail in later videos. In 1 chloropropane, the chlorine atom is shown after carbon 1 in the structural formula. And in 2 chloropropane, the chlorine atom is shown after carbon 2. What if we need to show a side chain? I'm showing you here methyl propane. A methyl group has a carbon atom and 3 hydrogen atoms. In the structural formula, we place the methyl group in brackets. As you can see, in methyl propane, a methyl group is bonded to carbon 2. So in the structural formula, we show the methyl group in brackets after the second carbon. Here's propan-1-ol and propan-2-ol. The alcohol group has both an oxygen and a hydrogen atom. So again, we place this group in brackets in the structural formula. Now, I just want to make an important point about the alcohol group. The covalent bond runs from the carbon atom to the oxygen atom. So you need to make sure that this is clear in the displayed formula. Okay, let's finish now by looking at the skeletal formula. The skeletal formula is the simplest possible way to represent the structure of an organic molecule. In the skeletal formula, we do not show the carbon and hydrogen atoms. In fact, the only atoms we show are in the functional group. Instead, we show the covalent bonds between the carbon atoms, plus the bonds to any functional groups. Now that sounds tricky, so let's look at some examples. Here's the displayed and skeletal formula of butane. As you can see, in the skeletal formula, I've only shown the bonds between the carbon atoms. These are easier to visualize if we number them like this. So we have a carbon atom at either end, and 1 at each connection point. Here's 2-chlorobutane. Now you'll notice that we've shown the chlorine atom, and that's because that's the functional group. And we've also shown the bond to the chlorine atom. Here are the displayed and skeletal formulas of methyl propane, and again we've only shown the bonds between the carbon atoms. Okay, I'm showing you here the displayed formula of 3-methyl hexane 1-ol. I'd like you to draw the skeletal formula, so pause the video now and try this yourself. Okay, I'm showing you the skeletal formula here. As you can see, the only atoms we show are in the functional group, and the only bonds we show are between the carbon atoms, as well as the bond to the functional group. Now, I just want to make one final point. You'll notice that I haven't shown the covalent bond between the oxygen and hydrogen in the functional group. And that's because it's not always critical to show every bond in functional groups. And as we look at the different functional groups, I'll tell you which bonds are essential. In the next video, we look at the general formula.
All right, is it clear?
Yeah. Yep.
Now let's talk about functional groups. It is a molecule in an atom or a group of atoms that give compounds some distinctive and predictable properties. For example, any molecule having COOH would tell me directly that it is a carboxylic acid. Any molecule having an OH group would simply tell me it's an alcohol. Anyone having a double bond would tell me it's an alkene. Homologous series is there for every functional group, starting from the first carbon ending at whatever number of carbons you want. For example, if we talk about the homologous series of alkanes, it starts with methane, then ethane, propane, butane, and it goes. If you look at the formula above, you can see that each formula has one more carbon atom and two more hydrogen atoms than the previous one. They differ by CH2. These compounds are the first four members, what is called a homologous series, which is a set of compounds with the same functional group, similar chemical properties and physical properties. They would all have the same functional group, same reaction, same chemical property, they would react in the same way, and physical properties would change depending on the increasing number of carbons. Alkanes, you can see over here, methane, ethane, propane, butane. You can tell their general formula as well. Then this is the general formula of alkenes. Alkane में, let's say if I want to write hexane, C6H12 plus 2 आपके पास 14 हो जाएगा. But if you want to write hexene, it is going to be exactly the double of the carbon atoms. Got it?
Right.
फिर alcohols में it's 2N plus OH. Then halogen alkane, whatever the halogen is, Br, Cl, and they can be added. Alkanes की बात करें, we can use the alkanes to illustrate the similarity in chemical properties of a homologous series. For example, when alkanes are burned completely in air, they all form the same two products, carbon dioxide and water. And this is the equation for the complete combustion of methane that you can see over here. Alcohols also show a different gradation in physical properties depending on the increasing number of carbon atoms. Methanol obviously has a lower boiling point than butanol because butanol has more number of carbon bonds. 3 carbon bonds बनेंगे इसमें because total of 4 carbons हैं. Chemical properties
So
would be
higher,
but physical
higher temperature to break them.
yeah, exactly. More number of carbon bonds, higher would be the boiling point.
Yes, to break the bonds.
Nomenclature is the method to naming these organic compounds. It is becoming harder to continue finding new names for many compounds, तो बहुत से use करते हैं IUPAC. IUPAC nomenclature rule is the International Union of Pure and Applied Chemistry, which is a rule made to name these compounds as well. Simple आपके पास rule होते हैं for nomenclature that you have to know. What is a prefix and what is a suffix? ठीक है? Prefix is known as, let's say, prop. And suffix would tell you if it's anol, it will tell you the functional group that it is alcohol. Prop will tell you the number of carbons that it is 3. This is known as the prefix. This is known as the suffix. Number of carbon atoms. This is shown by a letter code, usually 3 or 4 letters. Meth, eth, prop, but, pent, hex. ठीक है? And prefixes, suffixes वो बता देंगे. Multiplying prefixes, अगर let's say आपके पास 3 क्लोरो हैं, डाइक्लोरो हैं, means 2, tri means 3, and locants आपको बताते हैं position, which are added as dash. 3-methyl means that there is a methyl group attached on the 3rd carbon. ये आपके पास होते हैं locants. So this is known as the alkyl group. Alkyl group क्या होता है? Just subtract a hydrogen from the alkanes. मीथेन है तो मिथाइल क्या हो जाएगा, CH3। इथेन है,
Right.
C2H6। एक हाइड्रोजन निकाल दो, क्या बन जाएगा, इथाइल, दैट वुड बी C2H5। ये ब्रांचेस होती हैं, वी
Mm-hmm.
कॉल दिस दी एल्काइल चेन्स। So we can see how these rules work for some of the alkanes. The name of the alkanes end in ane. This is propane. अब methyl propane क्या होगा? The propane, which is the main chain and has a methyl on it. Then we have 3-methyl pentane. The main chain is pentane, but on the third carbon there's a methyl attached. What is methyl? CH3.
Uh,
Got it?
yeah.
Ethyl क्या होगा? C2H6. अब ये है
CH2.
2,3 dimethyl. That there are two
Mm-hmm.
methyls. One is on 2, the other is on 3.
3.
3-ethyl, 2-methyl. On
Yeah.
third
So
carbon
on
atom, there's an ethyl
there is,
attached. What is ethyl?
yeah,
C2H5.
uh, H3.
H5.
Then the second one, sorry, and on the second one it's methyl
And
pentane.
methyl is attached on the second carbon. We would start the numbering from here. Q, because the branch is closer. The branches are closer to the right hand side.
Yeah.
So we are going to start the numbering from here. If you look at alcohols, 3-methyl butane 2-ol को अगर आप देखो, that on we'll start the numbering कहाँ से? From where the main functional group is nearer. Alcohol है ना?
Yeah.
So it's nearer to left hand side. So 1, 2, 3, 4. And we'll write alphabetically, ठीक है? तो 3-methyl and 2-butane 2-ol. Got it?
Yeah.
Good हो गया. Then if we have to make dimethyl propane, that means 2-methyl है and they are attached on a propane. 3-methyl आपको name से भी structure आना चाहिए. So you'll be practicing these. I'll send you a video as well and a worksheet where you can practice these different IUPAC structures as well.
Okay.
Next, we have structural isomerism, which has 3 types: positional isomerism, chain isomerism, and functional group isomerism. Structural isomers क्या होते हैं? Which have the same molecular formula, different structural formula, या
Uh,
फिर displayed formula.
yeah.
So that is how you define. They have the same molecular formula but different structural
Different
formula.
structure formula.
Molecular formula C4H10 के आपको 2 possible structures थे. One was known as butane, but
Yep.
the other one is known as methyl
Methyl
propane.
propane.
Both of them have
Because
4
they're
carbons and 10 hydrogens.
but they're placed in different ways.
That was known as chain isomerism. Placed in a different way is known as chain isomerism. You just form a new chain. Positional isomerism क्या होगा? You change the position of the functional group, not the position of a carbon, not the hydrogen, whatever the functional group is. It can be an
Yeah.
alkene as well. ठीक है, for example, butene है. This is butene. You can change the position of the functional group. Make it in the middle. This is also what? Positional isomerism. This was butene. This is butene. You change the
Yeah.
position of the functional group. This was propanol. Now this is propan 2-ol. First the OH was attached on the first carbon. Now it's on the second carbon. We call it positional isomerism. Okay. So how do we draw structural formulas from the given molecular formula? You always have to draw a straight line. फिर bonds बनाए, वो practice कर लेना. ये आपके पास examples हैं. Nothing much for the structural isomerism. Let me show you one more thing. Where is the structural isomers?
Hi and welcome back to Free Science Lessons. By the end of this video you should be able to describe what's meant by structural isomers. And if you're following the AQA spec, then you should be able to describe different categories of structural isomers. Okay, I'm showing you here the molecule butane. Butane is an alkane with the molecular formula C4H10. Now there is another alkane with the molecular formula C4H10, and I'm showing you that here. This is called methyl propane. So as you can see, butane and methyl propane have the same molecular formula but different structures. Scientists call molecules like these structural isomers. I'm showing you the definition of structural isomers here, and you need to learn this. Structural isomers are molecules with the same molecular formula but different structural formulae. Okay, I'm showing you the alkane pentane. Pentane has the molecular formula C5H12. I'd like you to work out the different structural isomers with this molecular formula, and in each case I'd like you to name the molecule. So pause the video and try this yourself. Okay, there are three structural isomers with the molecular formula C5H12. First we have pentane itself. We then have methylbutane. And finally we've got dimethylpropane. Now I just want to make a point about methylbutane. You may have thought that there were two isomers of methylbutane, 2-methylbutane and 3-methylbutane. But these are actually the same molecule, as we always number the chain from the end which produces the lowest numbers. And in fact both of these molecules are called methylbutane. We don't need to include the 2 in the name, since the methyl group can only be on carbon 2. Okay, now some students will have drawn this molecule as a possible structural isomer of pentane, and they may have named it ethylpropane. This is actually incorrect. Remember that the name is based on the longest carbon chain. In this case, the longest carbon chain is actually 4 carbon atoms, and we can see that here. So this molecule is actually methylbutane. Okay, I'm showing you here the alkene pent1-ene. This has the molecular formula C5H10. I'd like you to work out the structural isomers with this molecular formula, and I'd like you to only look at molecules which are alkenes. I'd also like you to name them. So pause the video now and try this yourself. Okay, changing the position of the double bond gives us the structural isomers pent1-ene and pent2-ene. Taking pent1-ene, we can move carbon 5 onto carbon 2. This gives us the structural isomer 2-methylbut1-ene. If we take 2-methylbut1-ene and move the methyl group onto carbon 3, then we make the structural isomer 3-methylbut1-ene. Taking pent2-ene, we can move carbon 5 onto carbon 2. This gives us the structural isomer 2-methylbut2-ene. Now there is one point about this that you need to be aware of. Alkenes can also have structural isomers which are cycloalkanes, and I'm showing you some here. These cycloalkanes are structural isomers of pentene. Now I specifically asked you for structural isomers which are alkenes, and that was to keep things simple. Okay, I'm showing you the molecule 1-chlorobutane, and again I'd like you to work out the structural isomers of this molecule. So pause the video and try this yourself. Okay, this molecule has 4 structural isomers. We have 1-chlorobutane and 2-chlorobutane. Rearranging the carbon chain, we can now make 2 molecules based on methylpropane. These are 1-chloromethylpropane and 2-chloromethylpropane. Now some students may have thought that there's a 5th structural isomer with a chlorine atom now on the methyl group of methylpropane, and I'm showing that here. However, this is not a 5th isomer. This is just another way of drawing 1-chloromethylpropane. Okay, now sometimes 2 structural isomers can have different functional groups. I'm showing you an example here. These are ethanoic acid and methyl methanoate. Although I should point out that you won't see many examples of this kind of structural isomer in A-level chemistry. Okay, now if you're following the OCR or Edexcel spec, then you can stop now, but AQA students need to keep watching. AQA students need to be able to name.
All right.
Yeah.
Alkenes and cycloalkanes. If we talk about any alkene, let's say it's C4H8. Now, if you draw C4H8, it is obviously going to have one double bond and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. But I can convert it into an alkane by making a cycle. If I draw these in a cycle and now connect hydrogens 1, 2, 3, 4, 5, 6, 7, 8. See, no double bond was needed. I completed all 4
Yeah.
bonds of carbon as well and all 8 hydrogens as well. For example, look at this example. Okay, we have pentane drawn in cycloalkanes. Okay, cycloalkanes are all saturated. Remember that.
Yeah, because
Then
all
we
space
have
is used.
different types of reaction that you have to be vigilant about in all of organic chemistry. Okay, and the first reaction is known as addition reaction. This is only done with unsaturated compounds. Addition reactions are only done with unsaturated compounds which contain carbon double bond carbon. In addition reactions, we break the double bond and add something to it. It can be Br2 as well. It can be H2 as well. It can be chlorine as well. For example, ethene plus bromine made. We broke the double bond and attached bromine on sides. Got it? This was
Yeah.
ethene, right? I broke the double
Uh-huh.
bond and added bromine on sides as well. This was known as
Yes, so
addition.
it would be saturated.
Substitution
Yeah.
is replacing. You are replacing one species from another. For example, C2H5Br reacts with OH. OH replaces Br. Br comes in place of OH, and this is the product form. So from an halogenoalkane, alcohol formed by substitution. An alcohol was created from a haloalkane. Then we have
Right.
oxidation reaction, which is the addition of oxygen, which converts alcohols to compounds like aldehydes and then aldehydes to carboxylic acid as well. Oxidation is the loss of hydrogen or what you can call as gain of oxygen as well.
Yeah. Yep.
For example, alcohol reacting with oxygen produces aldehyde plus water. Reduction reaction can be called as loss of oxygen or gain of hydrogen. If you go opposite, carboxylic acid can be
Yeah.
reduced to aldehydes. Aldehydes can be reduced back to alcohols as well if you do the
So it just be
reverse.
opposite basically.
Exactly. Reduction में आप ये भी देखो कि ethene, if I add hydrogen to ethene, it becomes ethane again.
Yes, but alky.
This can also be classified as addition as well, hydrogenation,
Okay.
because you are breaking the double bond inside the ethene and adding two
Yeah,
hydrogens
so
on
it
the left
becomes
and
an
right hand
alkane.
side. Got it?
So we go from alkene to alkane.
Exactly. Look at this. The double bond was like this. I broke it down and added two more hydrogens on left and right.
Yeah.
Polymerization reactions, for example, addition polymerization is one type. It is also always done with unsaturated. Wherever you hear addition word, जहां भी addition का word सुनोगे, that means unsaturated के साथ हो रहा है. इसमें क्या होगा? We have a monomer, break the double bond, add two lines on left and right hand side, add a bracket and write N. This is a monomer. This is a polymer. Organic compounds contain covalent bond. For example, two carbon atom हो या carbon hydrogen हो, ये सारे क्या होते हैं? Covalent bonds, and because it's the bonding between non-metals. फिर दो और चीज आएंगी, and this is completely new. Now listen very carefully. There are two different ways for a covalent bond to break: homolytic fission, heterolytic fission. For example, chlorine forms